Hello everyone, this is INE Foundation Lab 2 section 7.1 LDP. Okay, this is MPLS section of INE Foundation Lab 2 and LDP Transport Label Distribution Protocol. Okay, let me explain MPLS concept and review some topics, then I will come back and configure this section. Okay, in MPLS network we have some terminology. I will explain all of this terminology later. Here we have in MPLS we have LSR. Let me tell this. This is we have LER and LSR. LER is also called ingress LSR. Don't confuse this LSR with this one in the middle. These two are different. Ingress LSR is our first LER in MPLS network, and egress LSR is our last LER in MPLS network. It is entry point and this is exit point of MPLS network. Then we have push, swap, and pop labels. Okay, let me show another diagram. Okay, let me explain. And I choose. Okay, in MPLS network we have customer edge router. Then we have P, what a provider edge. This provider edge is the same as LER, or this is because P1 is our first router, it is our entry point. It is called ingress LSR. This is ingress LSR. It is called ingress LSR. It's called LER or PE. Here, this is P1. This our provider router. It is called also LSR. This is our LSR. This is our LSR. This is LSR either. And this P2, it is our exit point. It is called LER, label edge router, or it is also called egress LSR. It is called provider edge, LER, or egress LSR. This LSR router in the middle, this is provider. The job is to swap our label. Swapping happens by P or LSR router. This ingress LSR or first LER its job is to push the label. Push is happening here. And pop, because this LSR is doing pop, it is called PHP also. I will explain this PHP later. Just to understand uh, this PE, we can call this PE into other name. One is LER or English LSR. Okay, let's clean this. Okay, MPLS terminology. We have customer edge router. It is located on the customer side. This is, I will open this page. The device located in customer side. This is our customer routers, and the device does not use MPLS, or it doesn't switch MPLS label. There is no MPLS for customer devices. Then we have provider edge router. This is provider edge. It is also called area or label edge router. And for first router, it is called ingress LSR, and the last one is egress LSR. It is also called ingress or egress LSR. It is located on the service provider side. Area routers do both IP lookup and switch MPLS label. When a packet arrives, first look up IP destination address and then use MPLS label. It first look up IP destination and then search the label. It is to push the label and so on. It receives packet or frame from C and then add MPLS label to it and forward toward the core. Okay, it is receiving and push or add label and forward toward the core. And it doesn't have to connect it to P other. It can be directly connected to each other. Okay, PE can directly connect it to each other. Okay, areas are the ingress or egress. I explained before. This one is egress. This one P2 is this one is ingress and this one egress. Or act as entry and exit point of our network. This is entry point and exit. An area push an MPLS label onto the incoming packet and pop it up of outgoing packet. It is pushing here and popping in outgoing packet. Okay, popping packet can be done by either LSR area, last area, or LSR. If LSR to the popping, it is called PHP or Penultimate popping. Okay, provider router. This is LSR. The provider LSR. It's located in the middle of MPLS network. It's located in the middle of connect to P router and other P routers. And not only MPLS doesn't do IP lookup. LSRs are doing only IP lookup. They do only IP lookup. They, excuse me, the LSR only do label switching or switch MPLS label. They don't do IP lookup. No IP lookup. IP lookup for LSR router. Only switch MPLS label. They only switch MPLS label or swap the label. Perform routing based only on the label, and switch packet based on the label or remove the label. This is swapping, switching the packet and or remove. If remove, if LSR remove pop or remove the label, it is called PHP, as I said before. Okay, MPLS label. We have a label push. Push means add the label to the packet. This is done by area or P routers. This is done by P pushing the label. We are swapping label swapping. It means replacing a label with another value. This is done by P or LSR. These are doing by LSRs. And we have pop, removing the label. This is done by either area or LSR. Okay, PHP. What is penultimate popping? Penultimate popping is removing the outmost label of an MPLS packet by LSR before the packet is passed to area. This is like here. PT removes the packet or outmost label. It removes the outmost label of MPLS. PT removes the outermost label of our MPLS packets and forward it to area. It is called PHP, open without popping. Okay, this is done by the implicit null label, and it has value of 3. Implicit null has value of 3. The implicit null label is advertised by LSR for all its directly connected or summarized prefix. This PT will have implicit null label if it do pop. Okay, we can verify implicit null by this show MPLS LDP binding label command on LSRs. The range of label value we have label 0 represent the IPv4 explicit null label. Label number 0 is explicit null label. This label indicates that the label stack must be popped. We have label 3, it is implicit null. The LSR indicate that the LSR pops the top label from the stack and forward the rest of the packet to the outgoing interface. Number 3 is implicit and 0 is explicit. Okay, in MPLS we have its own table, like our routing table. In normal routing we have RIP, routing information based table. We can see this table by show IP route command. Then we have FIB, or forwarding information based table. We can see this table by show IP save command. And in MPLS we have a table that are similar to this RIP and FIB. It's called lib, or label information based table. It is used to store label for prefixes. It's like our RIP one. And we can see this table by show MPLS LDP bindings. Then we have LFIB, label forwarding information based table. It is used for actual forwarding of MPLS packets. We can see this table by show MPLS forwarding table. Okay, show MPLS forwarding table is for LFIB, and show MPLS LDP binding is for lib, label information base. Okay, we have another terminology. This is BGP Core. BGP Core is a network deployment approach where service providers core routers do not run BGP. This is done by employing a tunneling mechanism of some sort, tunneling mechanism of some sort, most commonly MPLS. Okay, in BGP Core we don't have BGP protocol in core of our MPLS network. We have directly connected between PE by tunnel, some sort of GI tunnel, and so on. Okay, let me explain LDP, or Label Distribution Protocol. This is the core protocol of MPLS. Label Distribution Protocol enables peer label switch routers, or LSR, in an MPLS network to exchange label binding information for supporting hop by hop forwarding in MPLS network. Okay, its goal is to exchange label between our routers. This is the simple explanation. Each router locally generates label for its prefix and advertises the label to its neighbors. Okay, each router locally generates label for its prefixes. And Cisco has its own protocol called TDP, or Tag Distribution Protocol. Okay, this is important to understand. In general, there are two ways of establishing LDP session or peering. One is basic discovery mechanism, and the other one is extended discovery mechanism. Basic discovery mechanism is used with directly connected session. What directly connected session means? If an LSI is one hop from its neighbor, it is directly connected to its neighbor. Directly connected means LSI is one hop from its neighbor. And if LSI is more than one hop from its neighbor, it is called non-directly connected. Non-directly connected. Non-directly connected are extended discovery mechanism. An extended discovery mechanism is used with targeted LDP session. The targeted LDP session. For routers with multiple pair, and extended discovery mechanism are used in MPLS TE technology or Atom. This is for MPLS TE. In here, this is for service providers, most service providers that run ISIS as core, ISIS or OSPF as core, and MPLS TE. This is extended discovery mechanism. This was a large service provider network. Here we use directly discovery mechanism, basic discovery mechanism, or directly connected directly connected session. Here we use directly connected session. Okay, LDP discovery or directly connected. What is this? Is directly connected discovery or directly connected. LDP discovery runs on a UDP port 646 and the session is built on TCP port 646. Okay, LDP Discovery first sends UDP multicast error packet to discover its neighbor, then builds neighbor addresses using TCP. This is important to understand. It first discovers other neighbors, then uses TCP connection for neighbor adjacency. During the discovery phase, error packets are sent on UDP port 646, and it uses multicast address of this one to send LDP error packets to discover the neighbor, and uses UDP port 646 for source and destination, and it uses local interface IP as source. It uses local as source and 224.0.0.2 as destination. This is multicast destination. This address represents our routers on its subnet. First to UDP, then TCP. And TCP session is established using TCP port 646 and IP address of router ID. Okay, we can enable LDP by MPLS IP under interface configuration mode. And then interface that has MPLS IP enabled will multicast UDP packets. We can verify this by show MPLS interfaces. You show MPLS interface for verifying our LDP. Okay, TCP session is established using TCP port 646 and IP address of router. This is important to understand. And LDP Router-ID. LDP will use the router ID as the source of TCP session. To modify our router ID, we can use MPLS LDP Router-ID and interface command. This is interface, for example, loopback or physical interface. It's not IP address of our interface. This interface. We have to specify our interface name or type. By default, router ID is selected with the highest IP of loopback. If there is no loopback, then any active interface will be selected. Highest IP of any IP. Then highest IP of any active interfaces. Okay, we have LDP Transport Address. It is used to establish the TCP connection, and it's the source address of our LDP messages. It is like router ID. By default, it's selected based on the highest IP address of loopback. If there is no loopback, it is selected based on highest address of active physical interfaces. And to modify the transport address, we can use MPLS LDP Discovery transport address, transport dash address, and specify our interface. For example, loopback or physical interface, Ethernet gigabit or so on. Okay, we can filter our labels in MPLS. This is MPLS LDP label filtering. First, for filtering our label, first we have to disable a label advertisement by no MPLS LDP advertisement label command. This command is always default command. It is MPLS LDP advertisement label is default always command, and we can we can't see. But if we specify no MPLS LDP label, then we can see this command. No MPLS LDP advertisement is can be seen in OS, but this command we can see in OS. Okay, for label filtering, first we have to disable label advertisement by this command. Then specify which network to have labels. First we create access list, access is number, and permit our network. Then assign this access list to this command, MPLS LDP advertise label for this access list number. It is so easy configuration. First we disable advertisement, then specify network, then assign this access list to this command, MPLS label 4. Okay, we can have MD5 authentication for protecting between LDPs. We can protect our LDP session by MD5 authentication. For MD5 authentication, we have to use this command, MPLS LDP password required. This is for MD5 authentication. Any piece that tries to form a session without authentication will be denied. This is for MD5 authentication. Then we specify MPLS LDP neighbor and remote neighbor password and specify password. It is how we can use MD5 authentication for our LDP sessions. Okay, that's it. This is our MPLS. Let me show MPLS verification command. Okay, for LDP configuration, on the interface level, we specify MPLS IP. We can specify which protocol it should use by MPLS label protocol command. We can specify LDP or TDP. LDP is default. We don't have to use this command. This is LDP is default. We can also enable LDP on the OSPF process. On the OSPF process configuration, we can use MPLS LDP autoconfig command. It will enable all label for interfaces that OSPF is configured. And MPLS verification, to see if label is enabled or not, we can use show MPLS interface command. This command will show whether LDP is enabled or not. To check LDP neighbors, we can use MPLS LDP neighbor command or show MPLS LDP neighbor details. And to assign our favorite label number, we can use MPLS label range and specify range. For example, number label number range command. It is important to understand after changing our labels numbers, it is required to reload the router to take effect. We have to reload our router after this command. For this, we have to reload our router for this command to take effect. And to verify input signal, we can use show MPLS LDP binding neighbor command. Okay, that's it. This is our MPLS concept. We have LDP Peering. It first uses UDP, then it uses session, but then it uses session, TCP sessions. It uses UDP for hello packet, and hello packet are sent in UDP. The sessions are established by TCP and address of Router-ID. Okay, let's configure this section. Where is this one? Okay, this one. Enable LDP label exchange between R3, R9 and R10. Okay, let's open this. In here we have to configure MPLS. Then we have to enable LDP between 9 and 10. Okay, I have to use MPLS IP command. For this interface and for this interface. Okay, it is important to remember that between R3 and R10 we have PPP PPPoE connection either. We have compared this in previous section. Show PPPoE. Session. We have PPPoE showed on IP. Show IP interface brief. We have virtual template. This is server, and show IP interface brief. This is our client. We have to enable this on this interfaces dialer and virtual template either. We have two locations. This is one and this is two. I think we have to enable T9, 103 and this one. Okay, let's do it. Let's start by R9. Okay, config T. To show IP interface brief. Okay, interface. This is R9. I should select this interface, and I type simply type MPLS IP. Okay, I can verify LDP. I don't have to use this command, but I want to show this command. This is this MPLS label protocol. MPLS label protocol. We can use TDP, LDP, or both. LDP is default. I don't have to use this. If I want to use LDP, there is no need to type this command. I'll just type this. Then okay, that's it. This is a display and enable MPLS and this interface. I'll go to R3 interface. One is this one to write R3 R9, excuse me, MPLS IP. Then under dialer interface dialer MPLS IP. On R3 I have to enable on this interface MPLS IP on this interface MPLS IP. Okay, I can verify I am LDP by do show MPLS interface command. We do show MPLS interface command will show which interfaces will show on which interfaces labels are enabled. This is one, this is LDP, yes, operation, yes, and this LDP, yes, operation, yes. Same as here. Let's see. Okay, this part, oops, this part is done. Let's do now this other part. Okay, let's before concording, let's another verification command. The other one is show imperceptible neighbor. Show our neighbor. On this is TCP connection. P local, this is a loopback of 3 and loopback of 3 and loopback of 9. This is the port, as I said before, TCP connection. And let's see our table. Okay, let's see this if it is LSR or LER. Show LDP binding neighbor. Oops. Neighbor 10, 10, 10, 10. There is no neighbor binding for its LDP binding. And let's see our voting table. Show impulse forwarding table. Okay, this is our forwarding table. Okay, if you check this forwarding table, you can understand that we can find which hotel is LSR and which one is area. Here RT is our LSR hotel. It is there is no outgoing, there is no label. If you see, and it is popping our label. It is doing parameter popping. Yeah. RT is our LSR and R9 is our area. 10 is our area. If you check this table, you can understand the popping on. No, there is no label here. Now 10, I have 20, it is prefixes. I have 20 label for this 9, and I have it is actually now I have label 34 for this one. And next up is this point to point. So if I do show IP SEP 4999, next up is our connectivity over PPPoE. R9, this is local label and outgoing label, this is 17 for our loop bar. Okay, I can verify perimeter popping on LSR. Here, after is LSR, let's check. Show me the binding label. Okay, do show binding label for 10, 10, 10, and 10. Okay, this is implicit null label. And 4999, and for 99 I have implicit null. And I have label for other prefixes. This is Liberty 999, remove binding LSR, and Simpson null. For 222, it is remove binding and is label 60. Okay, 222 is for 16. If I check on 16 is for 222. And 444 level 17. And this is outgoing level 17, and this is 444. Okay, let me change okay, I will do this later. Let's do another. Okay. I'm gonna use this. Authenticate our LDP session with the password of this LDP underscore CCIE and ensure that the loopback 0 interface of all devices is used as the source of participant session. Okay, this is MD5 for authentication, and we have to just make sure loopback 0 is source of participant session. Loopback 0 is source of participant session. Okay, we can do this by changing Router-ID to loopbacks 0. Okay, on the this Router-ID, to modify Router-ID, we can use MPLS LDP Router-ID and specify loopback 0. Okay, config T specify MPLS command MPLS LDP Router-ID and specify loopback 0. Loopback 0. This is done. Yeah. Exit. Either. I have to specify this under this either. Then we have to authenticate. So I can verify this part. It show MPLS LDP neighbor. This is connection and loopback. Let's show our loopback. Okay, we have to authenticate MD5 for authentication. We have authentication. First we have to enable this password required. Password required is MD5 password requirement. Same as here. Oops. Same as here. Then specify our password. And push the neighbor. Okay, on R10. This is our manual. Put this on. MPLS LDP label. This is okay. We have R3. Three and 3. Password is necessary. LDP underscore necessary. R10. The remote is okay. It is the same for R10 either. And then we have 2 neighbor on R3. One is 999 and the other one is 10, 10, 10, 10. Okay, this is our authentication. Let's continue. This is done. Okay, R9 should only advertise a label for its loopback, and 10 should only advertise a label for its loopback. Okay, if we do show MPLS LDP bindings, okay, now he is advertising label for all its prefixes. You can see for okay, we have to only advertise label for its loopback. So let's do this. We'll do show MPLS forwarding table. I have label for all prefixes. Label for this. For this is 20. Local label. Icon label is 22. For 21 and 21. If I check here to show MPLS forwarding table, 22 is 21. This is 22. This is 21, 21, 21. Then RT is popping the label and forward it to R10. MPLS forwarding table, and this is all. Okay. Let's do only first. Only we can filter our label by MPLS label filtering. First, we have to disable label advertisement. Let's do this. R9. Disable label advertisement. Then I have to create access list. Access 9. Permit 999. Right click 000. And assign this to MPLS LDP advertisement number 4. MPLS LDP advertisement label and 4 advertisement label. We have 4 access list number is 9. That's it. Let's just verify. Let's come for this another 10. Top access list. First I have to disable no then access list 10 permit 10 10 10 10 0 0 0. Then I pay the label for this one. For 10. Okay, let's verify. Label 9999. Okay, now it's only advertised label for our 9. If I check previous command, let me check. In previous before I filtered our label, it was advertising label for all its prefixes, as we can see here. Shown binding label. It is advertising for all its prefixes, but after filtering, it is only advertising label for 9. Now let's check for 10. 10, 10, 10, and 10. It is only advertising label for 10. This includes all. The popping. level. And then preview, this was only available for all of this. The previous table, after filtering, it is only advertising for 10. Okay, this is done. And last part, configure R10 so that people it use gigabit internet. In this scenario, I have Ethernet instead of PPPoE interface. Okay, let's see on R10. If I do IP show IP slip 999, it is using PPPoE interface. Gonna do show IP interface brief, and it should use this interface instead of PPPoE. Let's check OSPF cost. Do show interface OSPF. Do show IP. Excuse me. Do show IP OSPF interface. This one. Our return is 0/1.103 is using cost of 10. Let's check this virtual template to show. To show tamam. have OSPF under this interface, and OSPF cost is 1. Show IP OSPF interface. Okay, or this one. This is for OSPF. I have to check this one. Doesn't show IP OSPF interface. This is 1, and this is cost is 1. Okay, I have to use, because the cost of our PPPoE interface is 1, and the cost of our physical interface is 10. And because 1 is lower than 10, it will take precedence. It will choose PPPoE instead of physical. Simply I have to change this one value higher than 10. Let me change it to 100. Config T interface. For changing this value, I have to go to interface with a template. And change IP OSPF cost higher than 10, and 100. So that physical interface is preferred. Because 1 is less than 10, then PPPoE interface is preferred over physical. Now 100 is higher than 10, then 10 will prefer. Okay, now to check the show IP SEF 9999, and it is using physical interface. Interface 999, and this is done. Okay, this was our MPLS section. I hope you have enjoyed this video, and thank you for viewing.